Hello, I am Professor Nagnath Hulle, and in this video we'll discuss about synchronous sequential circuit design. To begin with, we will discuss about the types of the sequential circuits. Basically, one is the synchronous sequential circuit and other is the asynchronous sequential circuits. In this particular video, we will discuss about only the synchronous sequential circuit design and its definitions or its terminology is it is a digital circuit in which state transitions are synchronized by the clock signal. Means all the flip-flops or all the memory elements available in the circuit changes their states at a single instant of the time. Whereas in case of the asynchronous sequential circuit is a digital circuit in which state transitions are not controlled by the global clock. Means there may be the clock, but it is not controlled globally. That is the basic difference between the synchronous sequential circuit and asynchronous sequential circuits. The types of the state machines used in case of the synchronous sequential circuit design. Following models of the finite state machine, that is FSMs, are used in the design of the sequential circuit, that is synchronous sequential circuit. One is the Mealy machine or Mealy model, and other is the Murray machine or Murray model. We will discuss about few basic terminologies related to the Mealy machine and Murray machine. As far as the definition of the Mealy machine is concerned, the state machine in which output depends on the present state and input of the system is known as a Mealy machine. Now here in this case, this is the state of the machine, memory element of the machine. And this is the combination part, and this is also combination part. We have one combination part at the input side and other combination part at the output side. Now look at this output. This output depends on state of the machine as well as input of the system. This is the input of the system. That's why it is the Mealy machine. Now here in case of the machines, it may be the Mealy machine or it may be the Murray machine. The two things are important. Always output of the memory element or flip-flop is always the present state of the machine, and the input which is going to be applied at the flip-flop or state is known as the next state of the machine. There is always the confusion among the students, what is the present state of the machine and what is next state of the machine. Present state is always output of the memory element or state, and input to the state or memory element is always known as the next state of the machine, and this is the diagram for the Mealy machine. Similarly, for the Murray machine, the state machine in which output depends on the present state only, and it is known as a Murray machine. In this particular case, look at this part. This is always state, this is the input combination part, and this is the combination circuit at the output side. But here this output, it depends on only present state of the machine, because output of the memory element is known as the present state of the machine and input to the memory element is known as the next state of the machine, that is NS. To have some prerequisite for the sequential circuit design, we should know the truth table for all the flip-flops, that is D flip-flop, T flip-flop, SR and JK flip-flop, as well as we should know the excitation table about this flip-flop. And first we will try to understand the prerequisites of the sequential circuit design. Here, truth table for the D flip-flop, I will not spare more time on this because already we have studied this particular thing at the basic level of the engineering. Now here for a D flip-flop, it is delayed flip-flop. Whenever input is 0, output will be 0. Whenever input is 1, output is also 1, but it is delayed by some time duration. Similarly, for the T flip-flop, whenever we have the 0 input, in that particular case it is a QN, means whatever the previous state is there, which is maintained. If the previous state is 0, then next state will be 0. If the previous state is 1, then next state will be the 1. And whenever its input is a 1, in that particular case, Qn bar is a complement of the previous state, that is toggle. Means here in this case, whenever input is 1, in that case previous state is 0, the next state will be 1, and if the previous state is a 1, in that particular next case will be 0. This is the truth about the truth table of the T flip-flop. Similarly, here in this case, basic points about the SR flip-flop is For S input 0 and R input 0, in that particular case, next state will be the Qn, that is same as the previous. You see, if the previous state is 0, the next state will be 0. If the previous state is 1, in that particular case, next state will be the 1. For 0 1 input, in that particular case, always its next state will be 0. For 1 0 input, its next state will be the 1, and for 1 1, it is undefined. For the JK flip-flop, for 0 0 input, J is 0 and K is 0, in this particular case, there is a Qn, there is no change in the state, that is a Qn plus 1, that is next state is same as the previous state, means if the previous state is 0, the next state will be 0, if the previous state is 1, the next state will be the 1. Whenever we are applying its input as 0 1, in that particular case, its next state will be the 0, independent of the previous state. Previous state may be 0, in that particular case, next state will be 0, and if the previous state is 1, in that particular case, next state is also 0, because here independent of the previous state, its next state will be the 0. Similarly, for 1 0 input, in case of the JK flip-flop, for 1 0, its next state is always 1, independent of the previous state. If the previous state is 0, then also its next state is 1. If the previous state is 1, then also its next state will be the 1. And finally, in case of the JK flip-flop, here if its inputs are 1 and 1, in that particular case, its next state is Qn bar. It is same as this, that is a T flip-flop, means whenever inputs are 1 1, in that particular case, if the previous state is 0, the next state will be the 1, and if the previous state is 1, the next state will be 0, that is the change of the state will be there, or complement of the previous state will be the next state. These are the basic fundamentals of the two tables of the T flip-flop, T flip-flop, SR and JK flip-flop. Now basically, we need to have a conceptual understanding of the excitation table for the design of the sequential circuit. Without understanding of the excitation table of the flip-flops, it is difficult to design the sequential circuit. Now here in this case, what we have, here I have considered this is Qn is the present state and Qn plus 1 is the next state. And this D input, T input, SR input and JK input, these are the excitations or inputs applied to the system or to the flip-flop to have a present state is this and the new state is going to be like this with application of that particular input. We will discuss in detail. Now here in this case, whenever, in case of the D flip-flop, whenever the input is 0, output is always 0. We are talking about the next state here. In this particular case, whatever it may be the previous state, next state will be 0 whenever input is 0 and it is 1 whenever input is 1. Now here look at here, previous state is a 0, next state we want 0. Then what should be the input applied? And in this case of the D flip-flop, input will be 0, the state will be 0 whenever the input is 0. Now here to have this next state as 0, we have to apply the input as a 0. To have a next state as a 1, we have to apply the input as a 1. To have a next state as a 0, we have to apply the input as 0. And to have a next state as a 1, we have to apply the input as 0. Means the designing of the sequential circuit using the D flip-flop is very simple, because in that particular case, the next state is very same as the input required to the flip-flop. That is the basic thing. Now here, if we are trying to understand the excitation table of the T flip-flop, now look at basically. In case of the T flip-flop here, if we want present state is 0 and next state we want to be 0. At what condition next state will be 0? Now here look at this flip-flop. If the present state is 0 and we want the next state to be 0, present state is 0, we want the next state to be 0, and next state to be 0 is obtained by using this. Because whenever input is 0, Qn means previous state is maintained. If the previous state is 0, next state will be 0, previous state is 1, next state will be the 1. But what is our condition? Our condition is that present state is 0 and next state we want to be 0. Present state is 0, we want next state to be 0, and to have a next state to be 0, we have to apply the input as 0. That's why here 0 input is applied. Now here present state is 0 and next state we want to be 1. Here this is possible in case of the T flip-flop only when we are applying the input as 1, because if the present state is 0, we want the next state to be complement of the present state, means we have to apply the input as 1, that is Qn bar. That's why here input applied is 1 in case of the T flip-flop. Similarly, in this case the present state is 0 and we want the next state, present state is a 1 and next state we want to be 0. That's why we are complementing the states, means again input should be 1. Here the input should be 1 in that particular case for the T flip-flop. And finally, present state is a 1, we want next state to be 1. There is no change in the state. If there is no change in the state, in that particular case input should be 0, because for 0 input of the T flip-flop, this is Qn, there is no change in the state. That's why here input applied is 0, means this is the excitation table for the T flip-flop, or preparation of the excitation table to be exact for the T flip-flop. Now we will discuss about the excitation table of the SR flip-flop. Now look at here, if the present state is 0, we want next state to be 0, then what should be the input applied? We will have possible conditions, we will check it out. What is the next state we want? Next state we want 0. Next state 0 is a possible, next state 0 is a possible under this first circumstance, that is 0, 1 is the input. One condition is that when the input is 0, 1, in that particular case next state will be 0. Another possible condition is that if the previous state is 0, the same state is maintained, in that particular case also the next state will be 0. And for that condition we should have input 0, 0. Means for 0, 0 excitation or 0, 0 input, the next state will be maintained as it is, and in our case the previous state or present state is 0 and the next state will be 0, means this is maintained. In that particular case we should have input as a 0, 0. In that particular case also the next state will be the 0. Here this is changing 0 and 1, means here final input should be 0 and don't care is the excitation or input applied for such state transitions, that is 0, don't care. If the present state is a 0, next state we want to be 1. We want the next state to be 1. The next state to be 1 is possible by applying input as a 1, 0. Means if the input is 1 and 0, in that particular case the next state will be the 1. Means here present state is 0, next state is 1. In that particular case it is obtained by applying the input as a 1, 0, that is excitation to be 1, 0. Next here, in this case, if we want the present state as if we have the present state as 1 and next state we want to be 0, to have a 0 as a next state, 0 as a next state, we have to apply the input as 0, 1. Now look at here, applied input is 0, 1, no other possibility is available. Finally, if the present state is 1 and next state we want to be 1, present state is 1, next state we want to be 1. Now here one possibility is that the next state to be 1, that is Qn plus 1 is the next state, is 1 possible whenever we are applying the input as 1, 0. One possibility is that if we are applying the input as a 1, 0, in that case also next state 1 is possible. Similarly, if we are applying or if we are maintaining the previous state as a next state, 1 as next state, present state is 1, next state is again 1. In that case, if we are applying the 0, 0 as input, 0, 0 as input, the next state is Qn. That is, next state is same as the previous state. Means if the previous state is 0, 0 is maintained. If the previous state is 1, the next state will be the 1. Means here for 0, 0 input also the previous state is maintained, and in our case, this final case, the present state is 1. That's why this 1 will be maintained. That's why in that case also we will have 1 as output. Means here in this case the final conclusion is that don't care 0 will be the excitation or input applied to have such transitions. Now here don't care 0 is the possibility of the excitation in this particular case. Don't get confused. In case of the SR flip-flop, there may be the confusion of the inputs are 1, 1, this is 1 and this is 1. This is not the input as a 1 and 1 which will give the undefined state. but this is the present state of the machine, that is output of the machine, and this is output to be in the next clock cycle of the machine. That's why it is anywhere not related to this 1 and 1, and this is undefined condition. Finally, we will discuss about the excitation table of the JK flip-flop. Here in this particular case, for 0 0, the next state is a QN. If this is possible, when the previous state is 0, the next state we want to be 0. In that case, it is possible by applying the 0 0 input, because for 0 0 input there is a QN, there is no change in the state. Present state is 0, next state will be 0. This is possible. In this case, it's 0 0 input, the previous state is maintained, and in our case it will be 0, because we are looking at this condition for a JK. Another possibility is that we want next state to be 0. For that case, another possibility of the input is 0 1. Is here whenever we are applying the 0 1, also in that case the next state will be 0, which is like this, that is Qn plus 1 will be 0. Means here 0 don't care will be the excitation or input applied to have a straight transition as a 0 from any other state. This 0 don't care is the condition. Similarly, in case of the JK flip-flop, if the present state is a 0, next state we want 1. Present state is 0, next state we want 1. Next state 1 possible by applying the input as a 1 0. If we are applying the input as a 1 0, in that particular case, the next state will be the 1 definitely. Other possibility is that, here look at this, 0 and 1. We are complementing this state. Present state is the 0, next state we want to be complement. In that case, applied input should be the 1 1, because in that case the next state is a complement of the previous state. Here present state is 0, next state we want complement, that's why applied input will be 1 1 for that particular case. In this case also the next state will be the 1, and that's why here 1 don't care is the condition of the excitation for the JK flip-flop, which is 1 don't care is the condition or input or excitation applied to the JK flip-flop. Next here, present state is 1, next state we want to be 0. Present state is 1, next state we want to be 0. Next state 0 is possible by applying the input as 0 1. We will apply the input as 0 1. In that case, next state 0 is possible. This is one condition. What is the other possibility? To have a next state as a 0. To have a next state as a 0, because look at here again, we are complementing the state 1, we are making 0, and this is possible. Complement of the states are possible. This is Qn bar. Complement of the state is possible by applying the excitation or input as 1 1. This here, if we are applying the input as 1 1, in that particular case the state will be complemented and the next state will be 0 for this particular condition. That's why input applied should be, that is don't care 1 for this condition. Finally, whenever present state is 1, next state we want to be 1. This next state 1 is a possible. Next state 1 is a possible by applying the input as 1 0. If we are applying the input as 1 0, in that particular case, next state is always 1. Next state is always 1, and we want the next state is the same as the previous state. 1 is the present state, next state is also we want 1, and there is no change in the state, that is a Qn. Means if the previous state is 0, then 0 will be next state. If we are applying the input as 0 0, in that particular case the next state will be maintained. Previous state is 1, next state will be 1. If we are applying the 1 1 input, means in that particular case also whenever we are applying the input as 0 0, previous state will be the mentioned. Means this is the condition, that is nothing but don't care, and 0 is the condition to have a transition of the state as a 1 and 1. That's why we are applying here excitation or input as that is don't care and 0. Don't care and 0 will be don't care and 0 will be the excitation or input applied to the JK flip-flop. That's all about the prerequisite required for the sequential circuit design. Thank you.